Um, okay, so now let's switch to LLMs, your favorite topic, I guess, and and then we'll get to robotics. Um, you know, at your intuitive level, what you say makes a lot of sense, right? This next token prediction thing is not really what's going to get us to a generalized form of intelligence. But isn't it the case that if this LLM black box is able to produce the right answer in millions of cases, it must be learning some internal representation that is perhaps a version of the world model you're talking about, right? Because otherwise it just seems by fluke it cannot produce the right answer time and again.
Well, I mean, the GPT architecture, right, is the biggest ones. They have many blocks, transformer blocks or whatever, layers, right, whatever you want to call them. And so there is, some degree of reasoning just in the propagation of signals within those blocks, but it's limited because the number of blocks is finite. I mean, it's fixed. And so the amount of computation that will go into the computation of a single token from the context is fixed, which means if I ask the system, is it the case that 2 + 2 = 4, yes or no? The system, of course, will answer yes. And if I asked, and we'll do a single propagation to that thing, right? If I asked, is it the case that P = NP? Okay, computer scientists in the room know what that be. It's going to spend the exact same amount of computation on this than answering whether 2 + 2 = 4. And that doesn't make any sense, right? You need a process by which the system can spend more effort thinking about more complex questions than about simple ones. So the trick that LLM people have been using is chain of thoughts, right? You train the system to produce more tokens than it really needs, so that it artificially kind of, spends more computation. But the amount of information that is carried between one step of the reasoning and another one is just a 3-byte token. And that's ridiculous. That's not the way we think. We think in terms of mental models, right? Which have nothing to do with language. Most of what we do has absolutely nothing to do with language. It has to do with our, representation, intuitive representation of the world. If I tell you, imagine a cube floating in the air in front of us here. Now, rotate that cube by 90 degrees around a vertical axis. I mean, you can readily imagine this, and you know that the cube looks exactly the same as when you got started, because you know what a cube looks like, and it's got a 90-degree symmetry. This has nothing to do with language. Okay, it's mental imagery or whatever. Most of the thinking that we do is of this type. It's only when we write code or when we do mathematics that we actually manipulate symbols and that it helps with the reasoning, but that's very specific. I mean, it only concerns a few % of the population.
Got it. So, I want to sort of, double click on both language, and then you talked about using video as a modality to learn from. Now, I guess one view is that language does encode a lot of, let's call it sort of world model rules. Like, when I write a sentence, for it to make sense to humans, it has to correspond to reality. I can't say, I dropped this bottle and it sort of went up. It won't happen. So that is on the language side. So it does capture information, beyond just the language aspect. On the video side, yes, there's a lot of data, but is it the volume of data that matters, or the number of interactions and the sort of the variety that really matters, right? Because
yeah, a lot of it is the bandwidth of the data, and which means in how much quantity is it available, but also the redundancy in it. So when I talk about this example, 10 to the 14 bytes, which is the totality of all the publicly available text, and it's actually what a 4-year-old sees during his or her life, 16,000 hours of wake time. People tell me, okay, but video is much more redundant. And I say, yeah, and that's exactly what you want. Self-supervised learning only works if the data you train it on is redundant. If you train a system on completely random data, it can't learn anything. It learns, it builds on the redundancy, and it discovers the underlying structure and redundancy in the world this way. And in text, there is just, first of all, not a huge amount of redundancy and not much bandwidth, and a limited amount of it. And we've already exhausted it pretty much. The only way people are making progress nowadays with LLM is through either fine-tuning or training on synthetic data.
Got it. Got it. I was just informed that the Prime Minister's security team is waiting outside, so we have to wrap up with, so let me ask you two more questions. Let's get to robotics, right? So earlier today, I, happened to spend a couple hours with Bill Gates, who had just spent some time in China, and then he came here, and I told him I'm going to chat with you on stage. And he, made the point that, back in the day, he thought robotics would be solved before writing essays, but the reverse has happened. But his reason is that it is the hardware, the robotic hardware, that has been too limited, right? The human hand has got some 27 degrees of freedom, and hardware is not there. So how much of the relative lack of progress in robotics is because we've been working with hardware that is very limited, as opposed to the fundamental model and the algorithms and so on?
Okay, there's several issues with hardware. So in the past, up until a few years ago, the case could have been made that the mechanics, the electromechanics and low-level control in robotics was not up to snuff with biology. I think that's not the case anymore. I mean, you see those robots doing somersaults and kung fu and whatever. Now you have to realize all of this is pre-planned, right? So there's no real sort of adaptability, understanding of the world or anything. It's all pre-planned with kind of a precise dynamical model written by hand. It's a bunch of equations. So there is a water model. It's just written by hand, right? So the actuator question, I think, is largely solved, except it's not as efficient as biology. Like, those humanoid robots run down the battery in like an hour or two. And obviously, we have more autonomy than that. So that's one question. What's not solved is sensing. So we cannot, as humans, we cannot survive without touch. We can survive without sight and audition, but not without touch. And touch is absolutely crucial. And if you numb your hand and you're asked to grab an object, you can't do it. It's very, very difficult without sensations. And so the hardware issue of touch sensing is not solved, but we could have robots that are as agile mechanically as a cat. It's not an issue anymore. We just can't make them smart enough to do what a cat can do. And in fact, there's a bolder statement there, which is that we have all of those companies building humanoid robots, and absolutely none of those companies has any idea how to make those robots smart enough to be useful. Except in very narrow tasks for which it's economically feasible to collect lots and lots and lots of data and training those robots by behavior cloning, essentially.
Okay, last question, and let's make it quick. So you've just started a company. Now, the world is swimming in capital investment in the LLM side of the world, right? I mean, your former employer, my employer, and a couple of others, colleagues spent more than the GDP of most countries, right, in the past year. So what would it take for that to change? So you're betting on a different way of building intelligence. Is it that you will show some step function improvement in capability, reduction in cost, improvement in safety? Like, what would, because otherwise the world will just go on the current train, right?
Yeah, so the old story was if you're Sam Altman or whatever, you convince your investors by claiming you're going to reach AGI just around the corner. I'm not, okay, first of all, I don't believe in the G in AGI, first of all, okay? Human level AI is an attainable goal, and there is no question that at some point in the future, not next year, we'll have systems that are as smart as humans in all domains where humans are smart. This is going to take a while. But what I tell them is that, we've seen in the recent decade and a half, we've seen two AI revolution, the deep learning revolution and the LLM revolution, which is the league on top of deep learning revolution. There's going to be a third one. And the third one is, AI for the real world, sensory data, video, AI that can reason and plan, which, Rahul Kembapati was talking about, and Surya Ganguly as well. And so that's the next revolution. That's what I want to build. That's what I'm building. And I'm, apparently being able to convince sufficiently many investors for that.
Thank you, Yann. Wonderful chatting with you.